And so another way we can consider the strength of an acid or a base is based on its conductivity. So that's going to be the conductivity of the particular solution that it's in. So if we have more free ions, it's going to be more conductive because the charge can flow more freely and easily through the solution. So free ions is going to be talking about when we have that dissociation of the acid or base. So remembering that strong acids or strong bases dissociate to a greater extent, so split into their separate parts, being the hydrogen ion donation or hydrogen ion accepting, and so that is what enables it to split into its parts, and that's going to occur at a greater extent when you have a strong acid or a strong base. So that's going to mean more free ions and hence a more conductive solution. So therefore, a stronger acid or a stronger base is going to make a more conductive solution. Now we need to touch on a concept which many people get very confused about. And so this is the concept of strength versus concentration. So it's important to note that concentration and strength are not the same thing. So concentration, as we've seen before, that relates to the molarity of something. So the number of moles per liter. Whilst strength is going to be about the extent to which it dissociates, and so hence strength is actually about the dissociation constant. So overall, this means that you can actually have a base or an acid that is really strong but quite dilute, or you can have one which is very weak but is actually quite concentrated. And so these factors are going to influence each other. So a strong, and particularly in terms of pH. So for example, like a very strong concentrated acid is going to have a lower pH than a weak concentrated acid. Or you could have solutions with the exact same pH, but one's a strong acid and the other is a weak acid. And so an example of this could be if you had a very strong acid that was very, very dilute, but you had a very, very weak acid, but it was very, very, very concentrated. And so they might have the exact same pH because pH is a measure of the concentration of hydrogen ions in solution. So we know that a strong acid is going to dissociate to form H+ at a large amount, whereas a weak acid is going to dissociate to form only a small amount of H+. But if it's very concentrated weak acid, then there may be the same amount as a very dilute strong acid.